All right. So again, some of you have been following along with this, and some of you may be new. And so what I wanted to do was I'll just explain it to everybody. So here is a schematic. And this is a schematic of the paddle that I'm going to build. And I guess what's different about this paddle is that we have these pressure sensors, and they adhere to to whatever you want them to. And these pressure sensors are kind of the main part of this Morse code paddle. So the pressure sensor is represented here in the schematic. And there's just a few components. There's a transistor. I've breadboarded it already, the circuit right here. So there's the transistor right here. And then there's a resistor. And then it just kind of connects to a 3.5 millimeter jack on one end. And then a power source on the other end. And, you know, most paddles that are out there don't require power, but again, this is just a little circuit, so there is a little battery in it. I don't mind. It's going to be pretty cool. So this sensor is going to go, once I get everything ready to go, I'm actually ready to solder. So here's a little circuit board, and this circuit board, we're going to solder all these components to it. And it's going to go, once it's all soldered together, inside this enclosure. I have a couple of ends that I have an end for this side and for this side. And I actually drilled holes already for you can see right here, there's a hole on the end. And so the pressure sensor is going to go on the outside like this. And the wires are going to go through that hole. I actually got to go out to the shop here real quick and drill a bigger hole. But, oops, I dropped it. What's going to happen is that's going to stick to the outside here. This sensor is right here. And then there'll be one on the opposite side too. And so I'll just, let me see if I can stick this together without it sliding. And so it'll be stuck right there. And so I'll just go like this to send Morse code dits and DAWs. So I actually had this all breadboarded. I did take this out because I needed to measure the hole in the enclosure. And so the hole in the enclosure was right there, and I measured it through. But when I got it through, I then realized I had to add this heat shrink to it, and that heat shrink actually made it so the hole's just a little too narrow. So I'm gonna have to go out and make the hole bigger because that heat shrink's got to go into that hole. We got to bend it a little bit because it's just a little too long. See here, it's just a little too long to go all the way in. So my first step is going to go out to the shop. I'll take you out there, and we'll drill these two holes. But I guess might as well, while I have it here, do a demonstration one more time. I know people who have been following have seen this already, but let me stick this pressure paddle back in. I think that this side goes to, let me just bring it up so you guys can see it. I think this goes to the positive right here. I'm going to stick that in to the positive rail. Gosh dang it. It's just not going. Hold on, let me straighten these out a little bit. All right, so positive into this rail here. And then this is going to go over to this pin right here. All right, just like that, I believe. Yeah, so, all right, so let me bend this down now. And then I'll give you guys a demonstration of the breadboarded paddle. I have here, this is the CW hotline, 20 bucks online. It actually allows you to communicate via Morse code with people directly through a wireless or a internet connection. You don't even have to have a computer. All you have to have is one of these boxes on either end and a paddle, and you can communicate through the internet to people on Morse code. So I'm going to plug that jack in there. And I'm going to I need to plug this into negative so that we get the power going through, and make sure it's on, and it is. There's a switch right there, so I got to make sure that switch says on. Okay, I think we're ready. I just need to plug in the power to this box, and then we'll be good to go with the demonstration. Then after that, I'm going to head out to the shop to drill these holes here. So there we go. So, yeah, let me tip this down. So that's that. So there's the DAWs, the dits. So it's There's the Morse code. Okay, so here's what we're going to do. First thing we're going to do, go out to the shop, get these holes a little bigger. That's step one. Next step is we're going to thread all of the components from the breadboard onto this, and I'm going to tape them on this back side so that they don't fall out. And then I'm going to solder each of the components and hope to God that I did it right. I don't want to resolder stuff. I think I've gone through the schematic. I've went through the breadboard here, so I think if I'm careful, I'll put these all on here and solder them. And then the next step after that is to test it, make sure that it works just like we did with the breadboard. We'll take this and test it. And the next step after that is to make sure we can get this in the enclosure. It looks like I need to shave a little bit off of one side maybe or something, or maybe we'll just put over that post. Okay, that might work. And we'll probably hot glue it in. And then after that, we just I think we'll be done. Actually, we just put everything assembled together and heat shrink the outer of this. If I have a big enough heat shrink, I might not, but we'll do something with it. So anyway, so that's where we're at. So let me go out here. I already have the drill bit that I want to use. I've already pulled it out of the kit, so it's just a little bit bigger hole there. So let's go to the shed and take care of that first and foremost. So get this bigger one. I hope I don't drill this enclosure too big. I guess if I do, I can order another one, but that's going to be a pain in the butt. I ordered this a while ago. I don't even know if I can get it again, but even bigger. And this one. And we take this drill bit too. Take them both back and put them in their proper place. We're back at it. So we'll put these back where they go. And I hope that's all the drilling that we need to do. I think all that's left now, we got to do add some heat shrink to. I wonder if I should get another layer on here. That looks, when I was trying to poke that through, look right there. It's a little concerning. Well, maybe just the one side. I don't know. Let me grab a piece of heat shrink out of my heat shrink box. Maybe the next size up and cover just the one that's like a little bit tattered, and then see if I can still get it through the hole. That would be this red one here. And box cutter. I should use scissors or something, but I don't. Hope I don't cut myself. That's been cut. Let's try it again. All right. Guess I better turn on my soldering iron. My soldering station actually. Let me show you. It's a dual. It has a on the left, on the right is the soldering iron, and then on the left is the heat blower, so that I can blow the heat onto the heat shrink and get it to work. So let's get this slid on here. Right there. There is no for this pressure paddle. There is no polarity on this. I mean, either side is fine. So don't get confused with the black and the red. I think that's going to work. I think that's still going to go through the hole. We shall see. Here, let me set this aside for just a minute. Pull this out of the way so I can get on the inside of here and blow that with heat. All right, we're good. So that's got to thread through this big hole now. There's no way that's not going through there. That's definitely going through, I guess I should have said. Yes, that's going through. Good. That's what we want. Bend that over. Voila. Perfect. All right. So that we're just going to keep right like that. And that's going to go into one of the boards. Okay. Let's just do one at a time here. So let's do the top part of the schematic first, the DIT. Let me show you this again. So what we'll do is we'll probably put the transistor in first. The transistor has three different pins, S, G, and D. I think that's the drain, the gate, and the source. And I have the data sheet, and it looks exactly the same. So pin 1 is D, pin 2 is G, and pin 3 is S. So let's just work on half of this at first, and get the first half on the board, and that's this board I'm talking about right here. And let's start with, let's just take this off. I think I want to go, let's see, I want to put this pin in, probably leave, that's probably going to be, I need a pen here. Hold on, let me get a Sharpie pen so I can mark this. I'm just going to point down and let's see here. Zoom in maybe? Does it zoom? Nope, it doesn't. Oh yeah, it does. All right. So what I want to do then, let me stop it from this. I'm going to say that this right here is going to be plus. This is going to be where the VCC comes in, and I'm going to call this one negative right here. And then those others are going to be just fine. So let me zoom back out. All right, so that sequence there, I labeled plus, and then there's another sequence I labeled negative. What I want to do is get the transistor lined up where you'll see over here in the schematic. Let me show you. You'll see that S goes to ground. If the flat part is facing you, that's kind of what shows here in the schematic. See, the flat part is facing, and so that means pin 1 is to the far left, pin 2 is the middle one, and pin 3 is to the right. And we just said pin 3 is S, or the source, and pin 3 here goes to ground. So what I want is pin 3 to go to ground, and we'll start in that direction. So pin 3 is right there. I just labeled it as negative. Now all this on the top is what's being soldered, so we actually want to run them through this side. So on pin 3, I'm going to turn this around so we're facing. Pin 3 is to the right because the flat part is facing. I'm going to flip it around so the flat part is again away from me, and then pin 3 then would go into where that minus is, that pad, and that's going to be, if I can get it in there, right there, and then we'll just run the rest through like that. Okay, so what we have is pin 3 here, pin 2 here, pin 3, pin 2, pin 1. Okay, so pin 1 will eventually over here will connect with the plus over here, but we'll get there. All right, so there we go with that. And let me make sure. I'm gonna have to get some tape here, probably, maybe not. I'm gonna solder this without even. I'm just gonna go ahead and solder this piece to get down here like this, and we're gonna turn that soldering iron back on. So one thing, guys, I have a fan. I'm not sure how noisy the fan is gonna be, but we shall see. Let me turn it on. Well, I gotta heat up the soldering iron first, but. And this is just going to run. Actually, I have one of these don't know if you guys have seen this before, but these are nice. Let me pull it back out just a little bit and show you. So this holds this will hold that in place. But I will definitely need some tape to tape the underside of it for sure, because it'll fall right out otherwise. But this is convenient because it helps hold this board in place. Get some tape underneath there. Let me flip this around. That's a cool thing too, is this flips, if I can remember how. I gotta undo both sides. Yeah. How about that, huh? Pretty cool. Really cheap, really inexpensive piece of gear to use for soldering, but very nice and convenient. So just need to, you know, just hold it in place. So like that. Come on. There we go. Now back over here, and we will solder these pins one at a time. Let me see if I can find my solder. Here we got some. Flans on. Let me get that, get this closer. Tin it a little bit. My hands are shaky. That didn't work. Let's try again. I need something to put my hand up against. There, that's much better. I think I got it that time. Maybe not quite there. Oh, that's too much. Dang it. But those are in place. A little bit too much there, though. Okay, so yeah, Dad Detailer, yeah. In short, it's a Morse code paddle, homebrew, using a pressure sensor. Right here, you can see one of them. There'll be one on either side of an enclosure. And so I'm sending, what it is just kind of a homebrew version of one of these here. This is a Morse code paddle here that I use in my ham radio shack. So what I'm doing is just creating a circuit for the use of the touch paddles. It's not pressure sensors. It's not a touch paddle. It's a pressure paddle. So the pressure, it's a pressure sensor, and so it needs a little 3 volt power source I have right here in this breadboard that I put together. But at any rate, let me turn off the fan here. Does that answer it for you? Here's the schematic, by the way. Let's see if I need to get. So what I'm going to do now, I just need to check and make sure that everything in this board is soldered correctly. So what I'm going to do, actually, I have this magnifying glass, and we're going to look at it very closely. Make sure there's no. Yeah, I can see that there is. It's soldered very well. I mean, I put a little bit too much solder on the middle one, on pin 2, but I mean, what's a guy to do? So that's done. Let me put you back over here on the stand, and then we will continue. All right. So I can take that paper off now. So there's the transistor for the DIT. And also, those of you who are new, I just labeled, get the pin out here. This right here is plus, the plus pad, and it's not connected to anything. This negative one, I have pin 3 attached to it. And we'll be adding some wires and stuff like that to make the circuit for, well, half the circuit really. Then we'll do the same thing on the other side. This is a very simple circuit though, because there's only 2 components on each side. So the next thing is this 1 mega ohm resistor. I'm going to take that out. And that mega ohm resistor, if you can see the schematic, well, let me just do this. Let me grab this is the outside of one side of the paddle, okay, with the pressure sensor. So one of these is going to go to plus, and then the other, so I'm going to stick this here. That's the plus, and then the other one is going to go to ground, but it's going to go to ground through the 1 mega ohm resistor. So in fact, let me actually do this kind of different. Let me put, see that 1 mega ohm resistor goes to ground and then it connects to VCC. So I'm going to do it this way. I'm going to put VCC, I'm going to put the resistor like, see, this would be like that probably on the other side though. Let's see. Yeah, ground, VCC. So this is to the G. G, as a reminder, is the middle pin. The gate is pin 2. So gate, pin 2. So in essence, what's going to happen is I'm going to run this resistor, except I'm going to do it on the bottom side here, but this is kind of what it's going to be doing. What I'm going to be doing is from the gate or pin 2 to the negative. So I'm going to run it like this, except for on the other side of the board. So you'll see that it's connecting pin 2 to ground. And so let me just look and see where those are. Okay. So I believe it's like this. Keyer, not Kaiser, yeah. Morse code keyer with pressure pads, exactly. That's exactly what I'm doing here. I got that in the wrong one. That's in pin 3. It needs to go in pin number 2. So right there. All right. So that's what that's doing there. We'll trim these in a minute, but I think I got that one. I don't even think this one's going to need to be taped in. What you got is, if you can see this resistor, if you can make it out, what we have is pin 3 goes to, or pin 2, sorry. Let me get a pen again and show you. This pad track right here is pin 2. In fact, I should just label it, then it's going to be easier for everybody. So ground, that's pin 3, this is pin 2, and this is pin 1. All right. Okay, so pin 2 has a resistor going from, and if you can see right here, pin 2 has a resistor going to ground, so I think that's going to be the way to do it. Yeah. All right, I'm gonna solder that. Fan on again. Hope it doesn't bother people too much. And where'd my solder go? There it is. This kit actually, just one more day. This is a schematic that I actually, a friend of mine named Tim from New Mexico gave me. He came up with it. It's actually, I think, in QST Magazine somewhere. But I don't know exactly where. George, I am making a pressure paddle, a Morse code pressure paddle. It has a few circuits, and so right now I have the schematic. I put it on the breadboard, tested it, it works, and now I'm actually soldering the parts into an etched board so that we can get it going. All right, so next is to solder these, and of course, if I make a mistake, then I'm just gonna have to do it over again, I guess. But let me pull this over to where I can work on it. All right, I think that one had too much solder as well. Yep, it went over the top of that other hole. That's all right, we'll fix that. And this one, though, we're gonna have to be very careful. I think I did it. Let's take a look. Yeah, it's not on that other hole. As long as I don't put anything in that other hole, I think I'll be okay. That's a horrible soldering job. Hey, but whatever. All right, I think I'm going to clip those leads now. I probably shouldn't in case I need to solder it, bring it back out, but whatever. I can get more parts. So let me grab those clippers. Turn the fan off. Yeah, I can see that middle hole right there, that the hole between, on line 2, there's like that hole that I almost soldered into. It's going to be a pain if I, actually, did I not get that right? I don't think I soldered that, I didn't. I left that, I'm not soldered all the way on the resistor here. This one, so I need to redo that, or get it better anyway. The old Heath kits, yeah, for sure. Yeah, I never did a Heath kit, but I sure do hear a lot of people talk about them and how wonderful they are. There, that fixed that. Now maybe I can fix this too. There. Fixed on both accounts. Still a horrible soldering job, but you know what? Like I said, I really don't care. You could do it a different way. I have another. Bubbles 3K. What does it matter? All the copper is connected. That's true. I was going to use this, but I'm going to use this. And yeah, it doesn't matter as long as if I put another. If I wanted to put another lead through here, and it could cause a short if it's. But oh yeah, you're right. It doesn't matter because it's all connected. You're right. What was I thinking? You just received, so Shay says you just received your level 3 electrical engineering. Very nice. That's awesome. I went to school at a local community college to get my electronics degree. So what is it? Electronics something or other for it's an associate's. I'm still a couple classes short. I don't know if I'll ever finish them. I took the gist of the courses and that was enough for me. Okay, so I think all we have to do now is to add this enclosure piece because we have positive going in to pin 3, pin 1. Yeah, I think what I need to do is put one. Let me just pull this out. So plus, so one end is VCC right here. Let me tip this up. So we know for sure for the pressure paddle, one end of it goes to VCC, and I have right here labeled the plus. If you can see it right here. Let me pull this out. It's already kind of come off, but plus is right there. I have it labeled right by the numbers, VCC. So and what's gonna this very end hole is what's the power source is gonna come in on. So it's fine to just put one end right there, and we'll solder that. I can just leave it like that and solder it. I don't think I need to. Yeah, I probably do. This is going to be kind of a pain in the tush because what happened? Oh my gosh. Okay, rookie mistake here. Rookie mistake. I was going to laugh at this one, right? I had the resistor flush against the backside. Then when I resoldered it, look what happened. So I'm gonna have to push it back up because it's like it dropped out. I'm lucky it didn't come all the way out, but that needs to be up flush against there, and it was at one point, but then I soldered it and it didn't. Here, I can do that with this. I can just push my thumb. There we go. Might have to solder it a little bit more, but I think that fixed it. Yeah, actually, I got a problem now. Maybe it's not. I think I burned off all the copper. I'm gonna have to add some, okay, because check it out. I think I burned off the copper. I'm such a doofus. Hey, but it's flush. Let me cut those leads, and then I'm gonna add some gloop to that side because it's obviously I burned off the copper. So maybe that's an excuse. Maybe I'm making excuses. I don't know. All right, I put some solder on there. There. All right, there we are. Still just fine, and we're flush on the bottom now. That's more like it. Okay, back to where we were at when we got sidetracked. We need this lead to go up into here, into the plus. I might not use this for this one. I might just let it dangle there. And solder it that way. Might as well put the other one in. So the other one goes to the resistor, which then leads to the ground. So that one is going to be number 2. So like that. So we've got the pressure paddle connected on both sides now. That's coming out too far. All right. I'll see if I can show you. I'll lift it up closer. So we have one pin going through the plus up here, and then we have one pin going through 2 down here. And what ends up happening is it'll go through the resistor, come across, and it'll also go through the transistor. So that looks like it makes logical sense to me. All right, fan on, and let's solder some more and see what other mistakes we can make. All right, here we go. Let me get another piece of solder. Another piece of solder. Did that do it? I don't know. Let's try this one. Why aren't you soldering? I think there's a connection. Fan off. Yeah. Did we get on both of those? That one looks a little... This one here looks like it's a little... Didn't get all the way. We'll try that a little bit more on that one. Because there was a hole there still. Again, too much solder, but at least it's covered. Okay. What a mess. Ugly. But it'll work, I think. Well, that's half of it. That's it. That's half. I think we're all set for that half. Now let's try the other half and see if we can get that one off the board here and get that working. What we'll need to do first is the same thing we did on the other one. We'll need to get some... See, this is why I put the heat shrink on, and because these bare wires, we don't want a short on them. When they get stuck through the hole, they'll get pinched together, and so we want to make sure that there's some insulation between them. So again, let's see if we can... I think I already have cut some heat shrink for both sides. Here's one. That's a little too long, is it? That's all right, I guess. There should be another piece lying around here somewhere. That's how organized I am, guys. It's just laying around somewhere here on my bench. Here it is. That's not going on. Oh, I see. Look at that. That's a horrible soldering job right there. If I do, you know what's going to happen is if I, let me see. Maybe I can get it to work. Look, here's the problem. Look at how that's soldered on. It's just like a gloop there, but that'll be fine. If I can just get the heat shrink around it, it'll work. You know what? I have some other heat shrink that's a little, there it is. There it went. All right, ta-da. Okay, good. Now, we're going to spread these out a little bit, and we're going to get the blower. And the hot iron, or whatever you want to call it. Because we don't want to short, that's for sure. I don't want to have to redo this. I have extra parts of everything, but it's awesome when it works the first time and you don't have to go back and troubleshoot and figure out what you did wrong. And that's what I'm hoping for this time, is all this soldering and putting together. I hope I plug it all in and it works great. It did when I did the breadboard, but we can hope. All right, I think we're good there. Again, those of you who are new, here's my soldering station. It's just something there's a local company that sells it, and so we have the blower here. I never can tell how to turn that thing off. Always have to do that. But so the blower here, and then the soldering iron unit there. So it's just a dual unit. This is pretty cool. What is the name of your the solder you use? Okay, so let me see. I can't remember exactly. I like to use the really thin stuff. For me, it's the best. But here we go. So it's Loctite. And it looks like it's going to be, where's the percentages? 60%, is that 60 EN diameter? So it's a 0.5 millimeter diameter. And looks like I think it's going to be 60%. Is it 60%? Is it down here? I can't tell what the composition is. I think it's going to be 60-40, but I'm not sure. I can't ever remember. I think that's what the 60 EN means, it's 60% versus the 40%. But there you have it. I got it off of, I think I just ordered it off of Amazon, if I'm not, but I ordered it a while ago. So, all right. So what we're going to do now, we have this, we need to thread through the other end of the enclosure. So we have this enclosure, other side of the enclosure here. And we'll run that through. And we're lucky that it fits. Yay. And yep, it doesn't go off the end there, just barely. But that's good. I want it as far on that end as possible. All right. This is smaller. These leads here are smaller. It's going to be interesting. But let's do the same thing here. Let's go ahead and just build the same thing on this on the other end of this, and then I'll connect the plus the VCC and ground to each other later. So that means that, let me grab the other piece of the schematic. Let's get this transistor off. And this transistor, by the way, is a BS170. You can also use a 2N7000, but this one in particular right here is a BS170. That information is listed right there. All right. Now this resistor, I completely mangled. You can see right here when I was trying to breadboard it. So that's a pain. Let me just see if I can get some tweezers out and try to straighten it out just a little bit. That might not work. I might just have to go with it. Well, all right, so let's stick this one. Okay, so for this one, it's the same. Let's see, is it the same exact? It looks like it is. If we look at the schematic, the dits and the DAWs in both cases come in through the D pin 1, go out, and then there's the G and S. So it looks like it's the same thing. So again, for a transistor, the front is the flat part, and oh, look what happened. Oh, shoot. All right, so this is trouble. I just ruined the transistor, and I need to figure out what I'm going to do, because I don't have another BS170. I have some 2N700s, but I don't have a BS700. Let me see if I can find one in my stuff. That is going to bore you guys to tears, I'm sure, going through my bag of all my parts. It's down here. I have all kinds of stuff in here, but going through that's going to, it might even be easier just to order another one. So you know what that means, guys, don't you? It means that we may be at the end of this stream. Let's see if I can get it turned around. Flip. There we are. All right, well, I really appreciate you guys joining, but I think it's going to be easier for me to just order another one of those transistors. I tried to straighten it out. It was already bent several times on the breadboard, and sure enough, the middle pin is completely gone. So there's no fixing it. So that's going to do it. So at this point, I guess I'm going to end the stream probably.